What is that scratching
the
noise?
sound of interrupts motherboard. But I need that.
All right.
I'll just unplug it myself.
Gotcha.
Oh, it's a Sangoma board.
There's a strange buzzing noise. This kind of thing happens in D.C. specifically when we have government organizations violating your rights and performing wiretaps of some sort under presidential authority, I'm sure. Did you know that somebody actually did a study of tinfoil hats? It came out of MIT. There was a variety of different tinfoil hats that the guy designed, and he showed that tinfoil hats actually not only don't protect you from certain types of radiation, they actually amplify certain signals. They happen to be in the frequencies that the U.S. government uses. So he posits that the government actually came up with the idea of tinfoil hats to encourage people to amplify the signals they were sending out to wherever. All right, rock the house. Who here has played with asterisks? So the best thing I just saw recently with asterisks was a guy that was able to send SMSs to his asterisk box on the internet, and it would automatically dial him back and give him a dial tone, and then let him dial anywhere out into the world over his cell phone, which was kind of sick, right? Of course, the number that he was using to dial in actually doesn't show up on billing, which is pretty cool. Asterisks can be used for a variety of different things, and Damon's going to cover those types of things. And before I turn it over to him, any questions about the con or anything else I need to answer? I keep asking that because I just want to make sure that nobody's confused or doesn't know where they're going or what room they're in or that sort of thing. Who's played in the Hacker Arcade yet? 3 people have played in the Hacker Arcade. There's a PSP. I mean, if you collect enough tickets and tokens, you can get yourself a PSP. There's a lot of really cool prizes in there, actually. Some really sick folks are setting up a skill crane. You can access it over the internet and use the skill crane to pick up even more prizes inside the crane. Everybody's like, I don't care about video games, man. Get on with like the talk. Okay, here's Damon, and give him a round of applause.
Oh no. Here.
Smith, the voice of the Asterisk open source PBX. Please be sure that your tables and seat backs are in the upright position and that your seat belt is securely fastened for liftoff. The telephone, as you know it, is about to go bye-bye. At this time, I would like to present Gregory Bainline, Asterisk developer and co-owner of N2Net. Thank you for calling, and enjoy the rest of your day.
All right. Well, that was usually that with guys at a con like this that people always just go, whoa, 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 there's a woman talking. I better listen. Before I get started, I first have to say I'm just awestruck to be here. The knowledge that's represented by the attendance of this conference is mind-boggling. What particularly blew me away was when I read a description about somebody that's talking about hacking the card bus on a laptop. That's just amazing. So thank you guys for actually giving me the opportunity to present. I feel like an idiot compared to the amount of knowledge that's here, but hopefully I can impart something of value to you and make you laugh along the way. Haven't been to a conference like this since I went to Nauticon last year. It's been interesting. So first and foremost, before we get started, I have presentation notes and all that crap, but really, I want this to be valuable for everybody in the audience, so I'm going to basically let you guys control it. I'll give you some points along the way where you can inject your questions, but just because of the fact that there's so much material, what I'm going to give you today is a very small sampling of a set of presentations that could actually span 8 hours, so I can't go over everything. So keep in mind that I'm going to try to keep things general, but and not get too specific. But we can delve into any more details. And of course, after this, I will be at the bar till 8:30. So if you want to come and have a beer with me and talk in a little bit more detail, I'll be happy to. Contact information. I'll show this again later. But for those of you that might want to email me, or just don't spam me, please, and don't sign me up for like porn lists either. You can find me at Damin-Asterisk.net. On IRC, I hang out on freenode.org on the Asterisk channel. And you can personally drop me an email. I'll do my best to try and respond to it and answer your questions. Can everybody hear me? Is that everybody's good in the back? I don't need to get. Okay, good. A little about me. I was born to a family of orangutans in the jungles of Borneo. I since shaved, and I'm the co-owner of a company called N2Net in Cleveland, which is a provider of mission-critical hosting. And we've been around 10 years, which in the internet industry seems like a lifetime, so we're celebrating that and just actually going into our 11th year. I'm really actively interested in the open source development model and have been for years, having seen the first release of Linux, and very active in Linux development and Linux advocacy, and that's the same type of thing that I'm doing for Asterisk now, because I believe that the telephone lines are the last sort of unopened frontier that we have, and we can sort of get in there with Asterisk and have a lot of control. And if I had this kind of information when I was freaking before I was 18, it would be amazing. So my official title, which I don't know how I got, I just sort of went to a couple of conferences and started hanging out with the right people. And believe me, by no means do I consider myself to be intelligent when it comes to code development. Most of what I write doesn't compile. That which does mostly crashes. That which doesn't crash mostly crashes everything else. So I basically am a bug marshal, which means I test other people's patches and I will make comments on them, mostly like, I have no idea what this does, but it didn't crash. And I am also the maintainer of the Ast-Wind project, which has now been deprecated, thank God. No pun intended, I'm not joking. It's Asterisk that runs on top of Colinux, running cooperatively with Windows. Anybody know what Colinux is? For those of you in the security, it's a great thing if you have to be forced into a Windows environment. It's actually a cooperative. It runs the kernel at the same time cooperatively as Windows, so you can have Linux and Windows at virtually no loss of speed, no virtualization necessary. It runs in Ring 1, I think, and has full access to Ring 0 stuff. I'm the maintainer of the legacy Red Hat Asterisk RPMs, which basically have not been maintained since the 1.0 release because there's really no need for that. There's a lot of benefits in the more current distributions, so I don't want anybody to blame me for that stuff working anymore. And I use Asterisk every day, both at work and at home. Full disclosure, a series of in the interest of full disclosure, occasionally I do shill for Digium, who is the people that sort of shepherd the Asterisk project along and sell some hardware related to it. So I'm here because of them. So take what I say with a grain of salt, just for your own edification. Just a comparison of before and after I shave. So here's basically what I'm going to try to get done here in like the 45 minutes that I have, and I just chugged a pint of coffee and a beer, so sort of leveling out. The first thing I'm going to do is I'm going to give you guys a basic introduction to VoIP, and to some of you people, they're fairly intelligent and in the know. This is going to be old news. Just bear with me. For those who uses VoIP every day, by a show of hands, okay, probably mostly Vonage. Vonage by a show of hands? Okay, good. You shouldn't use Vonage. Use whatever. Anything but. So I'm going to talk a little bit about VoIP and talk about VoIP technologies a bit. Then I'm going to talk about Asterisk, a little bit about the community, and just do a cursory overview of how the system is put together, how it's developed, and what the developer community is like. Then I'll wrap up and I'll take some questions. I will stop every now and then and ask if anybody has questions. Feel free to bug me. And I need some more of those shmoo balls for my daughter, so if you want to throw them at me, I'll try and catch them. So there we go. Without further ado, what is voice over IP? Very simply put, voice over IP is basically sending voice packets over the internet protocol. A very simple explanation of how it works is that we'll sample analog audio in chunks, usually 20 milliseconds in size, although depending on your codec and protocol, that can be more. We're going to convert that audio into a digital signaling format, or a codec, and then we're going to send that across a network connection as IP or UDP packets, or RTP packets. Then we're going to decode that stream to analog for playback on the other side. Now, when I say analog, I mean analog in terms of a speaker and a microphone, because ultimately that's what we're talking about when you have two people on the phone. Although if you're going into an IVR system or something along those lines, it doesn't necessarily always have to be analog. And thanks for whoever shut off the lights, because now I won't see what hits me in the face. Some basic VoIP terminology if you're starting to get into this world, things you need to know about. Obviously, we covered VoIP already, but PSTN stands for the Public Switch Telephone Network, or Mahbel, or the Great Satan, or in terms of what's just happened in the past couple of months, AT&T, which is SBC, which is evil. And then, of course, a codec is a digital signaling format. MP3 could be considered a codec because it will convert digital audio to analog audio. SIP and IEX2 are two protocols. SIP is the Session Initiation Protocol, and that protocol is most widespread in use. That's what most of your commercial services such as Vonage use, and that's what the industry is kind of standard on. It's kind of a piece of garbage if you ask me, but we'll get into that a little bit later. And then IEX2 is the Inter-Asterisk Exchange Protocol, which was really custom designed by the guys at Digium and Mark Spencer specifically, to be very lightweight and designed to be very efficient for the transmitting of voice. SIP can be used for all manner of things, such as video and all sorts of other stuff, and then IX2 is used traditionally primarily for voice over IP, but has been used also for video as well. A little bit of information about the particular piece of hardware that are involved in a VoIP deployment. First thing would be a proxy. I mean, by a show of hands, does anybody need me to explain what a proxy does? Okay, same thing in VoIP. It takes two different sides of a network and connects them together. And a registrar is something that's used to authenticate users, so you can register your particular endpoints against a registrar, and then that will know whether you're supposed to be taking these calls or not. Media gateway is something that actually translates between different media formats and traditionally is used to translate between the public switch telephone network and packet networks. And application servers, just think of them in terms of web servers. I mean, your voicemail is nothing more than an application now on a network. Interactive voice trees and all that kind of stuff, interacting with all sorts of great things. And I have some great examples of those applications later on. And ATA is an analog telephony adapter, something like a Cisco ATA 186 or a Sapura SPA 2001 or any number of different devices out there. Take your pick, most of them work. Any questions on anything I've covered so far? Okay. I can go into a little bit more detail on that a little bit later on. I'm going to just talk about like the main codecs that are used, and we can talk a little bit about, I'll just make sure I point out bandwidth utilization for those codecs. Anybody else? This, I don't know if this is really relevant, but you guys are all consumers to some degree, so why is VoIP relevant to you as a consumer? Well, it's the great myth. I mean, what you're being sold as far as the marketing and advertising is that if I switch to VoIP, I'll get free long distance. Okay, now I can't tell you how many CEOs and CTOs and CFOs I talk to who are like, well, we want to move everything to VoIP because it'll save us, you know, thousands and thousands of dollars on our bill. Well, yeah, in some cases, but in most cases, no. You know, it's a lot of hype. I mean, what it comes down to is that you're really trading off quality and reliability for features and flexibility. I mean, you have portability of your numbers. If you have a VoIP registered PSTN phone number, then as long as you register from anywhere on the internet and you've got a clean, non-NATed connection with SIP or some sort of crazy stuff to go through NAT with SIP, then you can have calls delivered anywhere you want. For example, in my hotel room, I plug in a laptop with a soft phone on it running, and it registers back to my Asterisk server, and all my calls then immediately show up in my hotel room, which kind of sucks because I really don't want to be that available, but it's kind of neat too because I can do that over a BlackBerry connection or a Bluetooth connection or a wireless connection or any way that I can get to the big bad internet. Bandwidth consumption? Yes. We'll get to that. I'll cover that when I talk about codecs from his question, and then I'll answer it. But just to sort of tease your, I've used it over an analog modem at 14.4. Yeah. The right codecs, of course, you sound like Mr. Roboto, but if you just are trying to get some important information across, that can work. Yeah, Speaks or ILBC or LPC10. Really, what I try to explain to my clients that purchase services from us is that VoIP is going to give you more choice and control of your telephony services. And it's going to make every dollar that you spend on your voice connection go a lot further. In general, if you look at the average cost of a telephone line across the United States, what is it, 18 bucks, 15 bucks a month? Just had a conversation with somebody out in the lobby who's spending $25 a month on Vonage. Okay, that's great. Average consumer uses less than 500 minutes a month on their home phone line. Average phone call length is 3 minutes. If you can get stuff, you can get minutes at 2 cents a minute, which is high in some cases, over VoIP, you know, you can go bank 50 bucks like I did and use it for a year and a half. So as far as money is concerned, there's different ways to slice it, but every dollar you spend, you can make go further. Why is VoIP relevant to your business? I mean, first off, from a show of hands, who runs a business that is a provider of services here? Because some of this stuff is really focused towards ISPs that are trying to become ITSPs. Does anybody really, I can go over this really quick, but as far as a business owner is concerned, this is really focused towards small business. Yes? No? No? Okay. Well, okay. Well, from a security consultant's perspective, let's just take all this stuff and trash it. VoIP right now is having a lot of trouble with security because it's tough to encrypt when you don't have a standard to encrypt. So not knowing who you're going to connect to on the internet, right now that's an issue. So a lot of the questions that security consultants you might get asked are, you know, what can happen? Can somebody sniff my traffic? And the answer is yes. We do that all the time for debugging. Ethereal is like our friend because we will actually sniff the RTP streams and reconstruct wave files of what's going across our network just so we can figure out DTMF issues, echo issues. We'll actually look at them in spectral analysis and find jitter and all that stuff. So security is important. You guys are going to be real important in trying to help us figure out how to get off of the PSTN and securely communicate with the rest of the world over VoIP. There has to be a catch. Yeah, I think I'll make some points about this. Voice over IP versus voice over the public internet. That's a distinction I like to make. I'm generally not a fan of voice over the public internet simply because of the fact that the public internet was never designed to be fault tolerant and reliable. It supposedly was, but reality is when you're using TCP or UDP, use a connection, you have no idea when or how that's going to get to the end of your, you know, the other end that you're talking to. And it could take a different route each time. One time it might go through Lithuania to get to Cleveland, Ohio. The other time it might go through California and then Chicago to get to Cleveland, Ohio. Now, if you were dealing with a protocol that's very latency, or a service that's very latency specific, I mean, I'm sure during the war on Iraq, everybody was familiar with the Iraq syndrome, which was basically, yes, standing here, oh, go ahead. No, oh, yep. If you are talking and somebody doesn't hear you for a second, that's a problem because you're going to get talk over all the time. So you have to either train yourself to actually deal with that or not. So voice over the public internet, very hard to control because quality of service is not a universal given. If I dump it off to UUNet, I have no idea what's going to happen to it once it gets into UUNet's network. And as much as many people might try to tell me, yeah, well, you can set TOS bits, I'm sorry, but they don't get respected out on the internet. So voice over private networks is great. I mean, it's awesome. Voice over IP is awesome when deployed on a network that has quality of service and end-to-end can be controlled so you can minimize the latency. And just imagine if you're talking and then all of a sudden the packet starts to sound like this and there'll be... That's what happens when you're delivering over the public internet. So when I say Vonage and all those other ITSPs, they're out there, you can buy services from them, but it is over the public internet, and small businesses are generally wary about that kind of thing because no matter how you slice it, running voice over a DSL for anything more than a couple of calls is stupid. I'm sorry, but it's stupid. If you're doing it for a small business, you are at risk. So think about that. The FCC, the wonderful FCC, since we're in Washington, I have to rip on them. These E911 requirements, what are they smoking? I mean, okay, we're going to give you the requirement that you have to deliver calls from any device, which is not geographically linked to anything, and we're going to have to be able to deliver it to the correct PSAP for that area, but we're not going to give you access to those PSAPs. Okay, good job. Good job. The FCC is generally, as far as I'm concerned, this is kind of ridiculously vague and short-sighted. I don't want that to be taken as I don't support E911 initiatives. I believe it's really critical for us to figure out how to do it. I just have no clue how it's going to be done. I mean, if I plug in my VoIP phone in China, what PSAP do I connect to? Yeah, exactly, New Jersey. Yeah, we'll get on a flight and we'll be there in 47 hours. So the FCC is kind of a hurdle to this as far as widespread adoption, but we're getting information, we're getting better, we're trying to figure it out. As soon as we can sort of, if we can beat the lobbying out there from the baby bells, you know, VoIP might actually have a chance of being something really, really good for consumers. But as far as the FCC is concerned, anything that's good for consumers now is probably not going to happen. Basically, the Telecom Deregulation Act of 1996 has been systematically dismantled and no longer pretty much exists. And they're looking to take away your ability to make a modem call, too. So, talk to your congressman and write. Customer expectations. This is probably the single biggest thing that I have to manage as a consultant. The PSTN's been around for a long, long time, ever since, you know, that first call, Watson, come here. It just works for the most part. Okay, yeah. Granted, everybody has an argument to that, but let's not get into that. When you pick up, you hear a dial tone, you dial, it generally works. 99 out of 100 times it works, which is pretty darn good. The biggest problem that we have when we put a new VoIP phone on somebody's desk is they haven't figured out that you have to hit the send button, because it doesn't know. It has no concept of 10-digit dialing or 7-digit dialing unless you program it for that. So the biggest thing is just use it like a cell phone. Oh, I get it. So that's one of the things. Those are some of the things that you have to negotiate. As far as the industry growing and becoming competitive, there's competition from the Airbox and the ILX, and you really expect Ma Bell to sit off while we take away their services? I don't think so. They have unlimited budgets. They've got lobbying groups in Washington, and you know what? We don't own the last mile as ISPs and ITSPs, so we're kind of screwed forevermore to be delivering it over somebody else's network, and until that changes. And please don't tell me wireless networks are going to solve that. Get one into like rural Minnesota, where the density is like, you know, 3 houses every 15 miles. So without further ado, that's the basics. Here, let's start with Asterisk. What is Asterisk? Well, 1999, this guy named Mark Spencer, who's a really, really cool, down-to-earth guy and brilliant beyond his years, needed a phone system for his small startup Linux support business called Linux Support Services. He wasn't able to buy one, so he just built one, and that's really how Asterisk started. A little bit more background on that, he was actually working as an intern for AdTran at the time, and they just kind of, he figured, well, what happens if instead of sending this to this piece of equipment, I send it to my screen? And so he sent it to his screen, and bloop, he got some strange character, and he said, wow, if I can get it into the computer, I can do everything with it. So, officially, Asterisk is an open source hybrid TDM and packet voice PBX and IVR platform with ACD functionality. Okay, what does that mean? Let's dissect that a bit. Open source, GPL, we'll get into that a little bit later, twist on that. Hybrid TDM and packet voice PBX means that we can connect to the traditional telephone network or packet networks. And IVR is integrated voice response, those annoying menus that you hear. I have a funny story on that with telemarketers. That's, we can do that very easily with Asterisk. ACD functionality is automatic call distribution. When you call a help desk and you get put on hold and you are the 37th caller in line with an average wait time of 6 weeks, that's what an ACD system is. So that's a big mouthful, but it sort of encompasses. Asterisk has a lot of features to it, which is why it's so hard to pack everything into a 1-hour discussion. You have to play with it to really appreciate it. Excuse me. Unofficially, Asterisk is quite possibly the most powerful, flexible, and extensible piece of integrated telecommunications software available. That's another big mouthful. Everybody knows what the asterisk means when you're talking about regular expressions, right? Matches everything. Well, that's what asterisk does, and when we like to describe it, we say it basically takes any call, anytime, from anywhere, and turns it into anything else and sends it off. So basically, we do it consistently and seamlessly without doing a whole lot to it in the middle. So really, instead of looking at it as an open source PBX, look at it as a telephony toolkit. It's there to do your bidding. You can integrate it with whatever you want, however you want, make it do whatever you want. Traditionally, it's Linux, developed on top of Linux. I do think it runs on the BSDs. I have no personal experience with that. And minimal hardware requirements. The smallest PBX that I've actually seen is a Gumsticks, which literally is from its name is a gumstick. It's a strong arm it's a geode processor running at 166 megahertz. Now that's literally this big. And that's the smallest as far as hardware. I have, and if you read the O'Reilly book on Asterisk called Asterisk, the Future of Telephony, you'll find many references in there to people running it on a Pentium 133. That happens to be one of my development boxes at home, which I'm the person that is always the person that finds things that are time sensitive because it takes so long to do things on it. But I can put 5 concurrent calls through it. So I like it. It's a little low-end box. What else am I going to do with a $10 box? Except maybe heat my kids' room. So it's a community-driven development project. Community input is really, really important in any open source project, but I think more so in Asterisk because there's so much flexibility in the system that if we don't have people testing all sorts of different things and breaking it in strange and fascinating new ways, the code will never get better. It's really, really, really disruptive from a technology perspective, too. I mean, just imagine that you can come into somebody and say, oh, you got this $40,000 Avaya box? Let's see. What say we drop that $10,000 a year in maintenance that you're paying, put in a box for $5,000 and do the same thing? People really like that. Any call, anytime, from anywhere to anywhere else. That's what you really need to know about Asterisk. We can take almost any technology in and send it out through almost any other technology. And as somebody was mentioning before, SMS integration, I mean, there's all sorts of weird things you can do with it. So the licensing model as far as the GPL is concerned, it is released and developed under the GPL, but Digium maintains exceptions to specific branches of the code. They basically require all developers of code to submit a disclaimer to their code before their patches are accepted into the mainline code that allows for Digium to license the specific branches of the code for commercial projects. So it is possible for you to go and buy a branch of the code that is not licensed under the GPL and be safe knowing that everybody that has committed code to that has disclaimed to Digium that that is all right. So from a copyright perspective, it's okay. You know what? There's a lot of people that like to debate this model, whether it works or doesn't work. Hey, if it's not compliant with the GPL, then let's find a way to make it. Or if it is, great. I don't get in that argument. But it allows companies to purchase the license rights, and there are several companies out there that are doing things with it that purchase the rights to it. So who is Digium? Because I keep mentioning them. They are the developer of the Asterisk open source PBX, and really they sell hardware. Asterisk is a piece of software that you can download freely. You don't have to buy it from them unless you want to. You want to buy a regression tested version, you can, but it's freely available, and there's not so many differences between what's in the source trees versus what Digium packages. It's just that they got a lot of people saying, well, we want to buy a box of Asterisk. Okay, here's a box with Asterisk in it. Most people compile it from source. These guys are based in Huntsville, Alabama, and they sell the hardware and support services for Asterisk. And these guys put out a lot of money, basically just supporting the community, and they get a lot of crap, quite frankly. Some of it's justified, some of it's not warranted, but they're a really good company. Their heart's in the right place. They want to help people, and I believe in what they're doing. It works out pretty well for everybody. So before I get into real-world applications, any questions so far? How am I doing on time? What do we got? Half an hour? Okay, cool. Excellent. Okay, no questions? All right, moving onward. This is the fun stuff. What can you do with Asterisk? Well, every small business, every large business, every business, most businesses, I should say, have phones. Some of them, if you're really small, have just cell phones, but most small businesses have a public branch exchange, a PBX, or a key system. So Asterisk can basically play in that world and completely replace a PBX. For example, in our company, we ripped out a Vodavi Star Plus system and replaced it with Asterisk. It can be used as an add-on application server. Say, for example, let's say that you have a Nortel system and you don't want to buy their CICS or whatever their voicemail module is called, which is ridiculously expensive. You can basically plug in some ports into Asterisk and use Asterisk voicemail features just to integrate with your PBX. It has an application called Meet Me, which allows you to use it as a conferencing server. In fact, that's how we do most of our development for Asterisk. A lot of us communicate over weekly Meet Me meetings, which are basically off the PSTN. It's all developed over the internet, so we just connect into a bridge and stay up there for hours and hours, and generally don't do anything productive until somebody from Digium shows up. Then we're all business. So they think we're on there for hours just working on it, which is why they buy us a lot of beer. It can be for a call center. If you're running a call center with several hundred agents, you can basically distribute calls on a variety of methods, like that guy over there slacking off, so we're going to deliver all the calls to him for the next 10 minutes, or we want to make sure that everybody gets the same amount of calls, or we want to make sure that everybody answers and hence spends the most amount of time, spends an equal amount of time on their calls. So it can be an actual ACD queue. It can be an endpoint for IP phones to register and convert. Let's say that you've got a legacy phone system that speaks H323 and you've got a new phone system that speaks SIP, and they want you to spend $20,000 on licensing to get the two to talk to each other. Well, you can stick Asterisk in between them and bridge that for free. Confound and confuse telemarketers. This is one of the fun things. I love it. Asterisk comes with a bunch of code examples that you can do anything with, but a couple of key applications it has. One is called Zappateller, which, remember those little boxes you could buy for like $19.95 off the infomercial that would basically play a reorder tone when somebody called? It would go beep boop. That would basically, if you have an automated dialing system in a call center, they'll blast out 1,000 calls at once, and whoever answers, they'll connect you. If they hear one of those tones, they immediately disconnect you and remove your number from the list, which is great because you don't have to do anything. You pick up, you answer, you play that tone, they take you off the list. Most people respect that, but some people don't. For those that are really annoying, if you don't have caller ID, then you can turn them into, plug them into the telemarketer jail system, which basically will force them to enter a valid caller ID, which you can then turn around and look up in an RBL with DNS, if you'd like. Yep, both sides of the war have the same weapons. And then it will basically put them into an IVR that will eventually lead them to leaving a voicemail for you, but waste a lot of time. And interestingly enough, somebody did a study not too long ago of the calls inbound for a year on his telemarketer jail system. And he then correlated as much as he possibly could. Given the guy that was talking about statistics earlier, I don't want to make too many claims, but because I'm not a statistician, but this guy analyzed the data and tried to corroborate the source ID, the source caller ID that was coming into his system, and the time they spent navigating. What they found is that if they tracked stuff back to commercial companies, as soon as they heard the reorder tone or they heard an automated answering machine answer, they hung up. But those that were tied to government agencies or were tied to fundraising for, say, like, elections, would navigate for 2+ minutes. So there you go. So the government employees will navigate the entire menu tree and leave you a voicemail. But it'll be things like, if you're calling to solicit funds for our senator, press 1. If you're calling to solicit money for poor children in Africa, press 2. And then we'll go through and give you a whole list of things about why, I don't believe in supporting this and that and this and that, and just waste time. It's fun stuff. This is the first application I built was a random application to prank a couple of friends of mine with random sound files from my sound library, which will basically use the cron command to fire off a command that waits a random period of time, anywhere between 1 to 6 hours at 3 o'clock in the morning, and will then call their cell phone and just pick a sound, wait till they answer, and just blast it out to them. And I get them yelling at me all the time for that, but I refuse to disable it. It's too funny. It comes with a calling card application built into it, so if you decide you want to get in the calling card business, one of the really cool things that I wanted to do, which I have never gotten around to it, was to actually replace my business card with scratch-off calling cards that would give you like $50 of value, but I would charge you at like 50 cents a second for your call. But basically, you would call in with this business card. It'd have my information on it. On the back, it'd have a key thing, but never got to it. And then I would play commercials for the 3 minutes and then hang up on you. A predictive dialer, which is one of those evil things I was talking about in the call centers, which is something that will actually grab like all available channels, make a call, and connect the first answered channel to the first available agent. You can use it for that. Home answering machine, if you want to be really, really bare bones about it. Most people at home don't really need a whole PBX in their house, but it's nice to basically have the ability to call forward your calls at home to something, or to basically when somebody leaves you a voicemail, have it show up on your PDA as a wave attachment. One of the really nice features of Asterisk, it integrates all these components pretty seamlessly. So all that aside, this is sort of a diagram of what the Asterisk development model looks like, which is remarkably similar to the Linux development model. Quite frankly, a lot of people from the outside look at open source and that's what they see. Unfortunately, it's really structured and they don't know what they're missing. So I fully believe that open source is a great way to go. And if you've got code auditing and stuff like that, it's just, I try not to run stuff that I can't look at the code for. Despite the fact that I can't really do much with the code, at least I know I have it, so it makes me feel better. So Asterisk's development model is very much similar to Linux. Mark Spencer is equal to Linus Torvalds, or Linus, or however you want to say his name. I can never get it right. The core developers have CVS commit rights, which we've now changed over to using Subversion from the 1.2 release. After the 1.2 release, we now use Subversion. 1.0 was released in Atlanta at a conference called AsterCon, which is devoted solely to Asterisk, and that is now end of life and only is going to get serious bug fixes. It's what they call the stable branch. It actually is really, really, really solidly built, and it has known bugs, and if you're going to run something in production, you want to know where it's going to fail, and I know all of the particular metrics that will cause it to fail, so I'm really happy running the old code because, whoa, it just runs and runs and runs. And as long as I don't tell it to do something I know that's going to make it crash, it just runs. The 1.2, which is now called Trunk, is the new release that just came out a couple of months ago. That's managed by a guy by the name of Drumkilla, Russell Bryant from Clemson. And he has a couple other people that are helping him on that. And development has already started on the 1.3 or SVN Trunk. I don't know what the hell they come up with these names for it, but 1.3 is in development. That's all I really care about. Neat new features in there. Digium actually employs a handful of full-time developers just to work on the code, and everything that they do comes right back into the kernel, the tree, not the kernel source tree, but the actual source tree for the PBX. It's community supported. Most of the times Digium's not answering questions on the mailing list, but they're hosting them. They're basically just making sure that the community is giving the right information to people. There's a developers mailing list where they will just beat you silly if you post anything that's not within the scope of their development. They have no tolerance whatsoever. And amazingly, there's like no spam on it at all. They started off being really, 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 really strict about posting stuff. There's an Asterisk users list, and most stuff gets redirected to that, and that gets 50 or 60 posts a day. It's pretty high traffic. We have weekly developer conferences, which I haven't been partaking in lately because I've been busy, but they're held online using the Meet Me bridge. That's kind of what our development conferences look like. And just if you want to see who's behind it, this was taken in Atlanta. And down here in the corner, this is always interesting. Right down here, you'll see a bottle of Jack Daniels and Mountain Dew. This was 3 a.m. Mark, this guy right here, Spencer, had to present at 7 or 8 the next morning for the keynote for 700 people. It was a crazy night. Anyways, very tight-knit community. We actually see each other a lot at conferences because there's a lot of voice conferences going on right now. So it's kind of fun. Any questions before I go into some of the metrics about what's going on under the hood? Time, we got 15 minutes yet? 20? All right, good. We're going good. No questions? All right, rock and roll. Under the hood, there's 4 different APIs within Asterisk that kind of make this thing work. There's a switching core, which is used to switch calls back and forth between channels, an application launcher, a codec translator, and a scheduler and an I/O manager, and then a dynamic module loader. Asterisk is pretty much built like the Linux kernel, such that you can load modules in. Applications are modules that get loaded in. Channels, channel drivers, which actually control what you can communicate with, are loaded in. And you can load and unload these to some degree without taking the system down. So you can basically make a change to your code, put the module back in, unload it, and then reload it, and your changes are there in the PBX core, which is kind of nice. It's got an application API, which lets you basically interact with the different components, the other APIs, such that you can build applications to do things, which is always nice. A file format API, which gives you all the tools. If you say, I want to write something out as an MP3, I want to take it in as, ULA from a standard analog line, and I want to write this out as an MP3, and then I want to send it to my, MP3 player. That can be done very easily. The channel API is what controls the channels, and then you've got a codec translator API, which can be used to translate from one codec into the other on the fly, which is kind of neat. Any questions on this before I go in? I'll dig into a little bit deeper some of the different API and channel drivers and stuff. No? Good. Under the hood, it's a modular architecture like I mentioned before. There is a console interface for it, which you can use for debugging and status. You can see what's going on in real time with the system. You can see applications developing. You can see channels being answered. You can see all sorts of stuff. Most of the components, again, can be loaded and unloaded from the command line interface. The configuration of the system is flexible. Traditionally, it uses text files in the etc directory or wherever you define that when you build it. Which is nice because if your kung fu is very good with sed and awk, you can do amazing things with the configuration files and force a reload and have your changes show up. And it's amazingly stable because you don't have sort of problems wondering if the database server that has all of your PBX configuration is available, which is one of the issues with the new real-time architecture, which sort of prevents me from using it. But the real-time architecture, which is available now in 1.2, allows you to store most configuration information into a central database or ODBC or whatever data source you want to use. There's a variety of different drivers that you can plug in, and if you're man enough, you can code your own, or woman enough, or just say lead enough. So the real-time system is awesome if you need to cluster a bunch of Asterisk servers. Like I'm working on a project right now where I have to figure out how to deliver 50 million minutes a month. And that's going to be like 20 different servers that all have to have immediate access to configuration changes, and the only way to do that is through the centralized database. So it's kind of cool. The channel API is interesting. This lets you interface with different pieces of hardware and or software through what's known as an Asterisk channel. The thing that started everything, it's a guy by the name of Jim Dixon who started something called the Zapata Telephony Project. And if you go online, you can check out all the history of the Zapata Telephony Project. But Asterisk adopted Zaptel as its platform, for better or for worse, to communicate and with telephony cards. So the Zaptel channel driver works with Digium TDM cards and several other off-market, aftermarket brands, and is all based on these telephony project designs, which are, by the way, open sourced. So if you are an electronic engineer and like playing with circuit boards, you can go build your own T1 cards for Asterisk. Just basically, here's the circuit board design. Go have them, create 1,000 of them and go to town, get the chips. So the Zap channel driver is typically what we use when we need to connect to the PSTN. The IAX2 channel driver, otherwise, they call it EEX. I don't understand how you get EEX out of IAX, but I mean, it sounds more like IX to me. But the Inter-Asterisk Exchange Protocol, version 2, is an extremely efficient, very simple voice-optimized protocol that, under the right conditions, can transport as many as 3 times more calls per megabit than SIP using G729. IAX2 supports something called trunking, so if you're making 5 calls to the same server, there's only one port that goes out, port 4569, which is UDP. Very friendly to NAT. When I use IAX2 and these little devices, like these little ATAs that support IAX2 called the EEXI, which I'll show you later, I just plug this thing in. We've gone through 7 levels of NAT on trade show floors just demonstrating, how to get an analog phone to work. Plug it in, gets an address via DHCP, goes out, calls back, registers with the server, and starts taking calls. No problems with NAT whatsoever. As opposed to SIP. SIP strives to maintain compatibility with RFC 3261. The Asterisk SIP channel driver allows you to communicate with SIP gateways, a media gateway, to gateway you to the PSTN, and SIP phones and other SIP devices. So, for example, Polycom or Cisco or Sapura or Linksys all have different products that support the SIP protocol. Those can all be tied into Asterisk. At home, I've got Grandstream, Linksys, Sapura, Cisco. I have virtually everything under the sun that's SIP, and I keep getting more and more stuff every month, and my wife's like, wow, you just do something with this. Like, I just want it plugged in. I want to see if it works. That's about the extent of it. But yeah, SIP is sort of ubiquitous out there now. Although because it's such a complex protocol, there are problems with individual interoperability, and that's why I make this last point. It's probably, Asterisk SIP stack is probably one of the more compatible ones out there and one of the more forgiving for silly stuff, because there is an amazing amount of interoperability going on with Asterisk, interoperability testing. I mean, there's not much that we can't communicate with SIP. And granted, the SIP stack can use some work and some scalability issues, but in the 1.0 and 1.2 releases, it's pretty damn impressive for an open source stack. There's several others out there that you could use if you wanted to hack them in, but the one that's derived is pretty much homegrown and works particularly well. I've seen people put 1,000 calls through a server using SIP with Asterisk. So H.323 is a protocol that's sort of an older protocol. It was one of the first sort of voice video converged audio protocols out there. The H.323 stack, or the channel driver that's in Asterisk, there's a couple of them actually available, but the one that's distributed is based on OpenH.323. The traditional big telcos use H.323 a lot, so if you need to communicate with some of their equipment, they're not about to scrap their millions of dollars worth of investments. So you can connect with H.323 if you need to. Other channel drivers that are available through the API are MGCP, which I don't really care about. You shouldn't either. SCCP, which is Cisco proprietary. Again, I don't care about it. If you have a skinny phone, upgrade it to SIP. If you can't do that, throw it out. OSS, which is the Open Sound System. This basically lets you send calls to your sound card, so you can gateway it to overhead paging systems or little devices that you put downstairs. Let me buzz you in kind of thing. And it also supports the new advanced Linux sound architecture as well. Any questions real quick on the channels? Everybody clear on that? Good. The Codec Translation API, which is what you guys had questions about. Codec Translation API converts audio codecs from one to the other and maintains a translation matrix to know what the cost is. So it knows how many milliseconds it takes to convert one frame of audio from G729 to G711 or G726 to G729. And when you're actually on the console, you can do a show translation to show what your costs are. Those decisions are made by the actual Codec Translation API and preferences that you set on your endpoints, so you can basically choose the low bandwidth codecs based on what your needs are. So codecs that Asterisk supports right now out of the box, I mean, there's a lot more that I don't have here, but the phone network as it stands today operates on G711 ULAW or ALAW, 64-bit point-to-point, 64K per channel. Now, again, that's bidirectional, so 64K up and 64K down. You add your SIP headers on top of that, you're going to get up to about 84K per channel. If you use EECs and use more than 2 or 3 calls, you basically are only adding on 64K for each additional call. So when you can and you need to send a lot more calls per megabit, you'll want to use EECs with G711 or any of these other protocols. The G726 codec is a codec that I like a lot because it strikes a good balance between bandwidth utilization and sound quality. These are ranked in order of perceptible, the best perception of sound quality out there. So G711 is the highest bandwidth codec that you can use right now, just straight out of the box without tuning. You could probably do some weird stuff with speaks if you wanted to. 726 comes after and all that kind of stuff. 32 kilobits per second with G726. Add your overhead for SIP and EEX, and like I said, it's a good sounding codec. And it's not encumbered by any kind of patents or royalties or licenses, so you don't have to worry about it. G729 is 8K per channel, which can be used with a 33.6 modem if you're using IX2, because the overhead for IX2 is lower than SIP. So you can use G729 if you can maintain 8K per second. You're pretty good. If you can't do that, you can go down and you can tune. Like this LPC10 is, I think, 4 or 3K per second. That works. That works kind of interesting. Like I said, it sounds like Mr. Roboto. GSM, again, GSM's cool. You can tune it, and ILBC is cool. GSM, ILBC, LPC10, and Speaks. I'm not sure that LPC10 is a open codec, but GSM, ILBC, and Speaks, I believe, are. Speaks is a great codec. Somebody had mentioned before. Speaks you can tune. I mean, you can basically tune Speaks down to 6K if you want, but not a lot of endpoints, commercial endpoints support it. So generally, when we're communicating with the rest of the world, we're communicating either G711 ULAW if we just absolutely don't care about bandwidth and we want, better than long distance quality, or G729. There's a protocol on here called G723, which is patent encumbered, which we don't have legal support for, although some people have hacked some codecs together off of the Intel reference code that works, but I wouldn't, legally you can't use it in the United States. Question? 5 minutes left? Okay, excellent. All right, well, File Format API lets you write things out in various formats. WAV formats, MP3, AU, GSM, used by a lot of applications such as voicemail, which lets you record messages and then send them in email, which is great. And if you're doing call recording, for example, if you CALIA, legal requirement for anyone that's an interconnected telephony or VoIP provider now has to provide CALIA support so that they can wiretap VoIP calls. So File Format API lets us write calls out. So that's another thing with VoIP. You never know who's going to archive your call or sniff your traffic and reconstruct your conversation because there's no encryption in most of it right now. Application API are modules of code that are used by the dial plan. Very simple. Applications like Answer, no need to explain that. It answers the channel when it rings. Background will play a file while waiting for a DTMF event, and then you can bridge somewhere. Congestion, play a fast busy, so every time my ex-girlfriend calls me, it rings and goes right into congestion. Dial places a call on a channel. Meet Me, MP3 player, music on hold. I mean, all this stuff is available. I don't have to go over it. Very simple applications that can be tied together very simply. This is an example of how to build a very simple application. Now, everybody that has a cell phone, if you want, this is a live demo. Feel free to call this, and you will see how this code translates into what you hear on the other end of the phone. This dial plan basically matches a call that comes in on this phone number, 216-920-3111, answers it, waits 2 seconds, plays back a warning that tells you it's going to be insecure, and then basically plays it again and hangs up. Tells you what number you're calling from, and I'm getting the hook, so I'm going to cruise through here. That kind of what it looks like on the console. All this stuff I think will be available online, so if you need more of it. Again, I'm rushing, so. API access. You can access Asterisk from the C API. You can access it from Perl, like with a module that runs Perl natively, one copy of it, which is great, like Res Perl for Mod Perl for Apache. JavaScript as well. The AGI interface, which is very much like CGI, so you can actually send command output on standard input-output and actually send it to shell scripts or what have you. The Manager API, which basically lets you see what's happening on servers from remote via TCP/IP socket. As you can see, I cannot cover this stuff in an hour. There's no possible way. So pre-recorded prompts, Allison Smith is really cool, and she does all the prompts for Asterisk. So she did my introduction. She's professional. All she does, she says she's a professional voice whore. She does voiceovers for things like Bell Canada, Victoria's Secret. This is just going to give you a real quick picture. These are the pretty pictures about how to connect Asterisk to the world. These cards from Digium, modular all the way up from 4 T1s all the way down to just a single analog port and everything in between. More TDM hardware. The EXE, the little blue thing, that's an IX ATA. This is a card that's vaporware right now, but it's supposed to be a DS3 card. A little ATAs, SIP phones from Polycom and Cisco. These are nice. Software phones that you can run on your software, on your Windows box or Linux box. X-Lite. So where you can go for more information, Digium's website, which, hell, you can't even read that. www.digium.com. The Asterisk website at www.asterisk.org. The Asterisk DOS projects, which actually has released a book under O'Reilly called Asterisk: The Future of Telephony, which you can get for free. It's under the Creative Commons license, so you can download a PDF of it. If you like it, support it. If you don't, don't. And then all the other information about the VoIP info. And I think that's about does it for me. Yes, no? Okay, thank you very much. More questions? I'll be at the bar. Thank you. By the way, I have like swag up here. It's not much, but it's like little cut sheets on Asterisk if you're interested. They're up here, and I don't want to carry them home, so please take them. Unfortunately, I'm not. Yeah. But I'll tell you what, just send me an email.